Hi, can I have the computer screen on all the projectors? Thank you. Uh, Hi, my name is Sachin, and I'm one of your TAs. So let's start the discussion. So first, let's look at some guidelines. Sanjay last time talked about some of the guidelines. However, we are still having some trouble with the communication, I think, so I'll just reiterate some of those. So when you're sending emails, please send emails to all the three TAs and do not send an email to professor. If we are not able to provide you with a satisfactory answer or we are not replying in a timely fashion, then I understand if you want to hear from professor, but otherwise it's better if you contact us first. The response would be much quicker, and overall, I can just say that the assignments have been designed by the TAs, so it'll be much more easier if we answer the questions, because sometimes what happens is professor might give you a hint which will be very biased because you're asking him and he's providing you with hint. He doesn't know, like, we're not telling those things to his, students, or what we are controlling and what we're not. So it's better if you talk to the TAs. Now he won't answer your questions until and unless there's something really wrong with the communication on our side. I've noticed that not a lot of you guys are using Blackboard. It'll be very convenient for everybody if you start using those, because the questions which you send us to the TAs, a lot of students have similar kind of questions. I guess we could go and post those questions online on the discussion board and then provide the answers. But sometimes it so happens that other students can help you, and if everybody is using the discussion board, you'll get answers much quicker. So, and before asking questions, it'd be great if you could check the discussion board, because a lot of information is already being provided in that. So there's a lot of redundancy in FAQs or guidelines or discussion board threads. I'm sorry to stress this again, but please do not copy paste your codes in the email and send it to us. It's really unfair to ask us to look at a code and out of context just realize what's wrong with it, or like we can't really program it or go through each and every code. We don't know what you're thinking at that moment when you're writing that code. Sometimes you don't even bother to explain what the variables are, and you just expect an answer. So it's really unfair. So I would recommend describe what the problem is, just in words what's happening, what kind of errors you're facing. Is it like a coding error, or is it like a logic error with your thinking with the algorithm? Then also provide us a pseudocode. Instead of providing us a code, just write down the flowchart, or in a couple of words, what you're doing next. So I guess by this, we would not be able to help you with syntactic errors in C or C++ or in MATLAB. However, we can look at the overall algorithms and help you with that. So I don't want to sound rude, but again, I'm requesting, please don't send us the codes. Let's look at some hints for homework 1. Since Sanjay has already discussed homework 1, I'll just briefly touch the questions which students have been asking most during the past couple of weeks. So for problem 1A to 1C, please show us the histograms, and you can manually choose the range for the background by looking at the histogram, but you should point that out clearly in your report, like, okay, this is the background is blue, and you can't see the other colors, and then you look at the 3 different histograms for the 3 color channels, and then you can say, okay, since the background is blue, the red and green have to be in lower range, and then you look at those values and you decide what is the range then you write down the range in your report, and then you can hard code it in your program. So a hard coding of the range is allowed. You don't have to really process the histogram and pick out the range using some method. If you want to, it's up to you. We won't really stop you. It's well and good. But if you don't want to waste time on that, it's cool with us. So and some students asked whether we could convert the image shape.raw or the extracted image for problem 1A to a binary image before extracting the individual objects. So, excuse me. So, yes, you can do that. However, we require the final output image to contain the actual color objects. Okay, so you can use the binary images, but you need to provide us with the color images. One thing you might have noticed that a circle is exactly not of 1 pixel width, the outline for circle. However, for square it is 1 pixel width. So we expect you to extract all the pixels. It should not happen that you just find out the radius using whatever method you are using, like crossing across the vertical center or horizontal center and then finding out the radius and just extracting the pixels on that radius. So that's not fair. You need to extract all the pixels. By the way, you can stop me anytime if you have any questions. Yeah. So so you need to extract all these images, even the pixel over here, which is an additional pixel, which is probably the 3rd pixel. Moving on to the next part. So a very frequently asked question is, do we have to use all the images? Yes, you do. You cannot select random pairs and say, okay, I'll use number 2 and 3. I'll take subtract those 2 images. Then I'll pick up, say, 8 and 4, and I'll subtract them. Professor gave you the general hint that you can subtract 2 images to obtain a difference image, and then you can identify the locations where is 0. However, what you cannot do is hard code any of those choices. Is that clear to everyone? Like, do you have any doubts with this? Because this is a very common question we've been receiving. So what we can do is the graders could change the name of the files. Like I could just change the name of 1st click to 7th click, 2nd click to 8th click, and irrespective of the name change in the name, the order, your code should still work. So if you're trying to hard code your name in the file, it won't work. Excuse me. Sorry. Well, why we are doing this is because if you select 2 images, then probably the question really becomes very simple, and you hardly do any automatic processing. All you're doing is you're selecting images, and then you might as well open the images in Photoshop and do it yourself. The point here is you need to identify the problem and use your digital image processing skills to solve it. So that's why we're requesting that you use all the images. Again, any questions on this? Yep.
I have a question.
Yeah.
So then after you're done with that part, you have the White House, and you're trying to get Superman out. Can you hard code that picture, because some of the pictures like have Superman cut off? I guess my question is, if you're changing the file names around, like you're gonna mess it up. So that's
actually, no, you can solve it without that. Still, you can solve the problem. I'll actually discuss that.
Okay.
I'll show my code in MATLAB and I'll just run it through.
Okay.
So I'll also give you some hints. So yeah. So one of the possible methods, as Dr. Ko pointed out, that you subtract 2 images, then you get zeros in the locations which are common to both the images, right? So if you take pairs of such images out of 8, then how many possible combinations do you have? 8 choose 2, right? So you have 28 combinations. So you could iterate through all the 28 combinations, but you would not need to, because after like couple of choices, if you go sequentially, like 1 1 1 2 1 3, you might have to try a lot of iterations. But if you do it randomly, it's quite possible that you'll end up with a solution much before eighth iteration or seventh iteration. Because yeah, so you could calculate the difference between all of the 28 pairs and then form a map which tells you where zeros have occurred frequently or even once. So you know when a zero has occurred, that means you know what is the location of that background pixel, right? So you can side by side create a map and a background image which you develop on the way, as you go as you increment with the iterations. So how do you know when you've recovered all the images? How can you identify at which point you have recovered the complete White House? Any guesses? Each time you take a difference, you get zeros, right? Next time you take another pair and do the same thing, you'll get zeros, not necessarily at all the same locations, right? Because if locations of Superman will change, you might have occlusion at other locations and you might have access to zeros at other locations, right? So when you get new set of zeros, you update a matrix which tells you whether this location has been previously filled or not. So when you have a flag matrix where you just keep account for all the pixels of the White House, once it is filled, like all the elements have been recovered, then you can just safely assume that it's done. So I would suggest you should use random selection for pairs. You can use random number generator, rand function, or even Gaussian random number generator. But whatever you do, you have to restrict it between 1 to 8, the values, and convert it into integers, 1 to 28. And then you can randomly select the pairs. So, sorry.
Why are we using rand function?
You can use any function. If you want to iterate, you can iterate through all the 1 to 28 set of pairs, but you don't need to. I'm saying if you go sequentially, like 1 1 1 2, it'll take longer to reach the final answer because the images will be in certain pattern, right? So you might want to randomize that selection so that you reach the solution faster. But it's just something if you want to do. It's not necessary. You can iterate through all the 28 iterations if you want to just take the easy way out. It doesn't matter if it's longer or shorter, because we won't grade you if it takes longer. So we won't grade you on that. But this is not the only method to solve this problem. There are much simpler and elegant ways to solve this problem. And now, since you've done filtering, I would just say this as a hint. Perhaps you could do some kind of filtering across the time axis. That's all I'm going to say. Think about it. Try to think in terms whether you can filter across the time domain. So anything is fine as long as you're not hard coding any image selections. Once you've extracted the White House, you need to extract the Superman image, right? So first, when you take the difference between the White House and suppose one of the images like first click.draw and the White House which you have obtained, you'll get zeros everywhere except for where the Superman image is there, right? So since blue screen was used to put Superman there, it was obviously in a rectangular box, so you'll see a rectangular error area. Now, you need to separate that. because you need to, because this will be located at different locations in different images, right? So you need to extract the superman.raw, right? So to do that, you need to have the same area in all the images, right? So that you can do the same process of what you did on White House. So suppose this is an example from third-click.raw. After I extracted White House, this is the subtraction with the third-click.raw. So I'm getting a Superman image, right? It's somewhere in the center. And then for the fifth click, it's right here, right? So the positions are different, right? So how am I supposed to subtract the two images and find out what is the actual Superman value? Because there is a lot of noise here, right? You see? And the noise is different. It's dependent on the background, right? So you need to separate clutter out all the noise, and you need to obtain the Superman, right? So in order to do that, you need to first stack the images on top of each other so that they match in the location, right? How would you do that? You can start by first separating out this from the black background. That should not be difficult, right? How would you do it? Yeah. Yeah, start moving row by row. You encounter the first pixel. You know you have hit the image. Then you go in the same row and look at the last non-zero pixel. You know you have reached the end. So you'll first hit this point, right? Then you'll hit this point. Similarly, you can go down, and this is the last non-zero row. So you'll say, okay, this is the third corner, and then you travel all the way down here, and you know you have the fourth corner now, right? So you have separated the coordinates for all the four corners, right? Now you also know the dimension, right? Because you can find out the distance between this pixel and this pixel, and this pixel and this pixel, right? So you can extract the Superman block, this block over here, right? You can do the same thing for this one, right? But what about the images which have a partial Superman? How would you distinguish between this and the other Supermans? Out of this 8 images, 3 will have partial Superman. Yes. So what you can do is when you calculate the size of the square, right, of all the 8 images, right, you can find out what is the maximum of the size, right? The maximum has to be the consistent one, and it will be repeated 5 times. So 5 times you'll have the same size, and 3 times you won't have the same size. You can ignore those 3 blocks, right? Because you don't need them. 5 is sufficient. Now using those 5 blocks of Superman, okay, let me just rewind a bit. Okay, so yeah, so you can use these Superman images, and you can crop them out on the basis of the size. Then you can threshold depending on the size, as we discussed. So you can ignore this image. Once you have that, you can just use, now you'll have 5 Superman images which you have extracted. Now you can use the same process which you used for White House to extract the common area. The common area in all these images is just the Superman. So all the noise which is different for different images, the clutter is all going to go away. You can use the same process what you use for White House. Either you can take the difference between 2 images and do the entire process again. So you have 5 images, 5 choose 2 combinations, right? Or if you find out the easier way out for the first part, then you can use the same method here, right? So since we have MATLAB here, I will not show the video, I'll just run the code. So here I'm randomly selecting images, okay? So in this one, 4 and 8 clicks were selected. So you can see this is a map, which is telling me, okay, all the white locations, I have found the background. For all the black locations, I have not found the background yet, right? And this is the recovered background, right? In the next iteration, randomly I got pairs 1 and 7. So now, since this area is free over here, I recovered the background in 1 and 7. This area is available, so I got the background for this area. Only this much portion is remaining. In the next iteration, it's all done. So it took just 3 iterations. It can maximum take roughly 8 iterations. It should be done by then. So this is the cleaned White House image. Now, this is the difference between the first click and White House, which you just recovered. So this is showing you the Superman, but as you can see, this one is clipped on the top, right? So you'll get a size which is smaller than the other ones. Now I go to the second one. This one is not clipped. Exactly, it so happens that this is the exact location. So similarly for third click, fourth, fifth, sixth, this is the last image which is complete, which shows the complete block of Superman. However, remember again, we can change the order, so you need to calculate the size and make, depending on that, make a decision whether you want to keep this block or not. So this block is not useful because it is smaller in size. So with this one, so yes, hold on. How did the? Yes, because there was certain noise. It's not completely exactly same. So you do get some estimate error. Sorry, because actually the Superman image which I'd used was pretty noisy. You can see there are some ropes here, and there's a lot of differential variation in the background, so I could not clear it completely. That's why there's a lot of mess around here. But in any case, so
How is the border of it rectangular? Did you extract it in a rectangular?
yes, I had to extract a rectangular Superman with the border and then paste it everywhere. So that's why it's rectangular. It was probably the same size when I did that. Oh, okay. Sorry, bear with me once more. Just stop. Now it took 5 iterations. So this is the Superman extracted from the second image, third image. Notice the background. The background keeps changing depending on where the Superman was located. So using the same process as White House, you can get a very clear image like this one. Then all you need to do is just place this appropriately in dogjump.raw. Cool? So I'm going to skip this. It's just the video of the entire thing which I just showed you. Let's move on to, yeah.
So can you hardcode where the dog is or where you're placing Superman?
Yes, that is one thing which is allowed, and we've been very clear about it in the homework, I think, right? You just manually choose the location, and depending on what size you pick out, the Superman you pick out, and just put it, that's fine. Yeah, as long as you mention the coordinates, that's it. That's all we ask. So for homework problem 2, a lot of students have asked, do you need to provide analytical equations for transfer functions? No, you need not. All you need to do is just show us the plots for transfer function, right? So for 0 to 255 on the source image and 0 to 255 on the target image, you can draw a transfer function. That's all you need to show us. You don't have to solve it analytically. It's not really, it's pretty involved, so it's okay. For 2C, please remember to normalize the PDF because you're truncating it between 0 to 255. So when you're truncating the Gaussian density function between these discrete values, you'll be throwing some mass away. So the CDF would not sum to 1, but you want the CDF to sum to 1 because you want to apply. So it'll be approximate PDF, but that's okay. So once you have calculated the PDF for 0 to 255 values, you can take out the sum of all those and just divide each individual element by the sum. So that it sums to 1, right? You can normalize that.
The time is 8 o'clock.
And try different values for mu and sigma. So this is just a sample PDF for Gaussian. And this is the CDF. Now, for this part of the problem, until now what you've been doing was you take the histogram of the image, you construct the CDF, then you try to map it to a uniform PDF, right? But now you want to, this is your source PDF and this is your target PDF, right? So how do you achieve that? You can do this process for both, right? You can find out how you can go from here to here, right? Same thing you can do from here to here, right? But then once you have figured out the transfer function for this process, and once you have figured out the transfer function for this process, you convert the pixel values of this range to a uniform range, right? Then you can reverse map those depending on this transfer function to this range. Do you understand? Is it clear to everybody? It sounds complicated, but it's very easy actually. So you're doing the same process twice. First, you're finding out the transfer function between the source image and the uniform distribution. Then you find out the transfer function between the Gaussian PDF and the uniform distribution. Then you convert the pixel intensity values from source image to that of the uniform CDF. Now the pixel intensities would have been modified, right? 22 intensity could go to like 30, for example. Then if suppose color intensity, gray level intensity of 50 maps to 30 here, then what would you do? You just map that 30 to 50 here, right? And using the same logic, you can develop a transfer function between this and this directly. Come on guys, give me some response. Is it clear? Or you have some doubts? Anyway, I'll assume that it's clear to everybody. So this is the histogram for Barbara. Actually, this was constructed by inverse Gaussian PDF. So it makes sense that you use Gaussian on this one. And this is the CDF. So you can see that these are two Gaussian regions. I just split them and across the intensity and constructed that image. Let's move on to problem 3. So a lot of students have again asked, how do you do the quality assessment? We have not asked you to do quantitative quality assessment like to calculate PSNR or SSIM. Since students are interested, the other TA, Co, will discuss this in next discussion section. But you don't have to use that for this assignment because we have not given you the original images, so you cannot evaluate PSNR and SSIM. You need the original image for that. And we have not given you the original images because the main reason being, if you look at the histogram for original images, you can just quickly figure out what kind of noise is present. So we just chose not to give you that. So all you have to do is do a very subjective analysis, look at the clean noises and say, how does the filter perform on the smooth regions. Define a smooth region. What is a smooth region where the intensity is, not varying too much? And then what is an edge region? What is a texture region? So how is it performing on these regions? How is your filter performing on these regions? Is it corrupting the signal itself in the process? Then how is the blur? So try to answer these kind of questions. I know it is very difficult when you're looking at the results for different parameters and to select which one is best by just looking at it. But the difference would not be so much. Eventually, you'll have to choose one which you think is visually the most appealing one, right? We won't penalize you for like a penny here and a penny there. It's just equal for anything. So as long as you're discussing different parameters and saying, okay, if I increase the window size, then what happens? Then how does it affect the edges? How does it affect the blur region? If I change the filter parameters, like there are 3 filters which professor has discussed for 3 linear filters for Gaussian noise cleaning, right? H1, H2, and H3. So you can try all those 3 and discuss what is the advantages and disadvantages of changing the weights across the filters. Then you can try different window sizes like 3x3, 5x5. And as far as boundary extension is concerned, you don't have to do it because you're not calculating PSNR. So we would not really penalize you for 1 pixel length border across the image. I think that's okay. If your window size is like 5x5, we'll have 2 pixel border, which is not cleaned. But if you want to do border extension, well and good. So there are several ways by which you can do border extension. And I would recommend that you do it because eventually down the line in assignment 2 or 3, you will need to use the function where you extend the boundaries. So you might as well write the function right now. So what that function should do is basically, can I have the overhead camera? Copy it. So this is your image and your filter is say 5x5. So when it is centered across the first pixel, you need at least 2 pixel range outside, right? So you can repeat this row here, then repeat this column here, and you can repeat this pixel over here. That is one way. The other way would be to repeat this row 1, then repeat the second row. This is like a mirrored reflection across the edge. Okay? So these are common ways, and there's one more. I can't think of it right now on top of my head. You can just repeat the borders, take this, and you can just take it in this order. So you can do border extension. You can write a function which takes in the image size, image, and by how much you want to increase the border, and what method you want to use. So you can reuse this function later in different assignments. And I'm sure you'll end up using it. So you might as well write a code for that. And once you're done with the filtering, you can again take out the size of the image which was originally meant to be. Okay? Can I have the camera on the computer screen back again? For the mixed noise, you should look at the histograms. Actually, I'm giving a lot of hints, right? You can look at the histograms for the 3 channels and see what kinds of noise are present. You can point out which noise very easily looking at the histogram. Or just looking at the image itself, actually. You don't even need to plot the histogram. Which noise is very easily spottable? Salt and pepper, right? So if you plot the 3 images separately, or you look at the histograms, you'll find out that not all the images have all kinds of noises. Okay, so first find out which channel has been corrupted by which noise. It could be more than one, or it could be just one. So then the question is, if it's a mixed noise, what kind of filters would you use? If it's a mixed noise, then okay, you already know one is Gaussian noise and the other one is solid paper, right? So each noise requires its own kind of filtering. Now, since it's a mixed noise, you can first filter out one type of noise and then the other one, right? So is the order important in which way you process? You should think about it. Now, sometimes the images could be so noisy that you have to apply the same filter twice. Suppose I'm using linear filtering to remove the white Gaussian noise, right? I use a 3x3 filter. Then I see that there is enough noise again. Then I use another round of 3x3 on this filtered image, right? So now when I'm doing this, if I use a 5x5 instead of 3x3, the question I'm asking is, can I first use 5x5 and then use 3x3? Can I first use 3x3 and 5x5? Would it really matter? So if you go back to the basic concepts of DSP, where you have H1n and H2n impulse response of two filters, then what is the impulse response of the overall filter? Wrong. Did I say those filters are linear? That is one assumption, okay? So there's, I think, enough hints to cover this problem. For bilateral filtering, a common question is how do you select CNS? You don't have to select CNS because you've already given, those are the Gaussian functions. However, for sigma C and sigma S, you can refer to the paper which we've provided. I've uploaded the papers on DEN. You can access the reference papers with other files for the homework. You can read it. There's common recommendation by the author what range you can select. But I would rather suggest that you try certain values, because all you have to do is just change sigma and run the code again, right? So you can yourself see the impact. And once you see the impact of varying sigma C and sigma S, it will be very apparent what is the functionality of C and S. To understand what C does, what S does, you could even remove C completely. You could just use S, then see what happens. Then you can use S and remove C and just look what happens and explain what is going on, because it is crucial for you to understand what is going on in the filter. Why does it perform so much better than the other linear filters which you'll be using for the other part of the problem? So another interesting thing you could do is use a very simple image with like half image is black and half image is white, and see how it performs on the original image. You don't even have to put noise in it. Now, since there is no noise, what does the filter does? So if you use a normal filter and there is half white, half black, what will happen with a normal filter? Blurring? Are you sure? Where? Blurring where? Only on the edge. Everything else will be same because it's just constant, right? So when you use bilateral filter, what happens? Just look at that and how affecting this, how changing the sigma affects your filters. Just those observations will help you write the report. And report is very crucial. Even if you do all the problems and you don't write a report properly, you don't explain what you've done, and you don't justify your parameters or choices, then graders might penalize you. And it so happens that every time first homework is like this, where you learn a lot, but I don't want you to go through the same ordeal, so just try and be more explicit with what you're writing. NLM has been discussed in detail, so I'll just quickly touch the basic. So you look at this region between the white wall, there's a wall, right? So basically this neighborhood, and this neighborhood are pretty similar, right? So they'll have similar weights and they'll help each other in filtering. Whereas if I choose something from here, it will not help. It makes sense. Basically, it uses law of large numbers. Stats class. recall that when you take sum of a random variable over n terms and n tends to infinity, then the sample mean tends towards the sample mean tends towards the actual mean. Okay, so that's why you will eventually end up with the right image. So that is the basics for NLM. One thing which I would like to point out is we've asked a question where you have to distinguish between the two kind of filters, bilateral and NLM. Actually, bilateral is kind of a special case for non-local means. So to recognize that, look at C and S and look at the distance function in NLM and try and explain that in your own words. I have to move. A very common question, memory allocation. We've answered this on discussion board, FAQs. Still, we've been receiving questions about the same thing. So this is just a sample way to do it. I'm using malloc here. What is the difference between malloc and calloc? Yeah. So I need a three-dimensional matrix, right? So what is this? 3D pointer to the pointer to the pointer to the final value, right? So you can, at any given time, you can start assigning values to or allocating memory to the outermost pointer first, right? So the outermost pointer would be pointing towards a 2D array, right? So first you do that. This is what this for loop does. Then you go one step deeper and then you look at the one-dimensional array, which is of the size of dim. So first you initialize the memory location for the pointers which is most outside. Then you do for the 2D array, and then you look at the one-dimensional locations, right? So if I have a 4-dimensional array, what will happen? This will go inside a for loop. There will be another initialization before this, right? Do you see that? Anyway, you can look up at more examples on this link. There's plenty of examples online. Just search for dynamic memory allocation. Okay? BM3D filtering. I'll quickly try to cover some of it. Operator, can I have the notepad? Or the camera on the notepad? Sorry, I couldn't prepare the presentation for this part, so yeah. I'll just... Okay, so in non-local means, what do? You look at a pixel. This is a pixel in your image. You look at its neighborhood. Then you look at a pixel surrounding this. You take its neighborhood. You calculate the distance between them, right? Now, instead of doing this, you look at a block. You're not doing noise cleaning for a pixel anymore. Excuse me. Sorry. Yeah. So suppose this is the block you want to filter. You find out all the blocks which are similar to this. you stack them in a column. So this will be a 3D array, right? Now, how would you know two blocks are similar? You can use various metrics, whether it be like the Euclidean distance or SSIM if it's taught to you by them, or any other. You can try various things. The author suggests Euclidean distance, so just use that. So you have this block of similar images. You have to threshold it somewhere, and you have to ignore the images which are far away from this block, right? Can you please remove that top left subfeed? Yeah. Okay, so now this stack of images, you'll filter them together. What is the advantage of filtering them together? Instead of using just one block like in NLM, if I'm trying to filter these images together, again, motivation is the same. You have similar blocks, so you're using the information of all the blocks together to filter them. So how do you do that? You convert this 3D array to the frequency domain using wavelets. Now you'll ask what is wavelets, and that is beyond the scope of this course. So let's assume that it's a kind of a Fourier transform. Actually, I shouldn't say that because it's not, but it's kind of a transform which transforms the signal into a space where you have both time and frequency information. So just take my word for it and assume that you can do a 3D wavelet transform to obtain one filtered image or 3D filtered images. So now, what wavelets, you know what is DCT, right? DCT is often used in compression because it can reduce the number of information content to very few amount of bits. Similarly, in wavelets, you can now threshold the values. Suppose I threshold these values, it will be like varying. So if I threshold them, the higher frequency values would be the noise, right? So I convert this back to a single image. This is the cleaned image or the estimate for all these blocks. Okay? So for a stack of blocks, you did wavelets, then you did thresholding, inverse transform, and you obtained one estimate for all these images, right? Now, since you're getting an estimate for a block, suppose these were the 3 blocks in my similarity index, I'll get an estimate for that, right? Now, suppose I'm using this block, which I'm denoting by, so suppose this is another similar block, and this is another similar block. So these 3 will also result in one estimate, right? So I'll have more than one estimates for this common region, right?
At a time.
So how do you obtain the estimate for this? You can use various methods. You can use just the average or Wiener filtering, which is very common. Now, what is Wiener filtering? Forget about it, the details. It's a very advanced form of filtering, which is adaptive to the local statistics of the region. So just use that. Actually, you're going to use the code, so you don't have to worry about that. Anyway, I think the next TA will continue where I'm leaving.